Stefano Santarelli. I'm the CEO of INDICAL Bioscience. We are an innovation-led global diagnostic company, and I have the privilege today to introduce Dr. Erik Karlsson, who probably many of you already know. Dr. Karlsson is the director of the National Influenza Center of Cambodia and the regional WHO H5 reference lab. He also has many other roles as an internationally recognized expert of respiratory diseases, working alongside FAO, WHO, and just to mention a couple. But above all, I think Erik is an innovator. Erik is driving the future of diagnostics and really changing the legacy approach of how we look at monitoring diseases. And we as INDICAL share the same vision and passion for innovation, and we're really excited and grateful to working with Erik on many exciting projects, some of which he will share with us today. And I really look forward to engaging with all of you after this talk to really shape the future of the animal health industry together. So our booth is actually 4590, and I look forward to really seeing a lot of you and engaging in helpful discussions. With that, Erik, over to you.
Thanks, Stefan. Is this on? We're on? You're going to make me blush, man. My whole face turns red. But yeah, hi, my name's Erik. I hope you do know me in some way. Hopefully it's not bad. But I'm thankful to INDICAL to let me take these innovative products that they make and other innovative products out into the field and play with them and see what we can do to move forward. So I'm going to talk a little bit about the work we do in Cambodia and regionally, the efforts that we're trying to do to expand surveillance, to make it more cost effective, to make it maybe tell us a little bit more. And mostly I'm just going to show you a lot of fun pictures, I think. So let's talk about avian influenza. Obviously, there's been a lot of talk about avian influenza lately. These are just the number of events that have been reported globally between 2022 and 2023, so January 1st, 2021, or 2022, and the current date. As you can see, there's a lot of red dots on that map. If you zoom into Asia, sorry, that's a little blurry, but you can see that there's still a significant number here in Asia, even though the virus has been endemic in the region for over 20 years. And there's likely many, many more here that are unreported or undetected as well. What's interesting is that, so I span both the human and animal side when we're looking at these things. So what's interesting is that if we look at human seasonal influenza, that pretty much went away during the pandemic. So if you look at human seasonal influenza, when they declared an emergency of international concern and then the pandemic, for pretty much the whole year afterwards, we didn't have a lot of flu, except in Cambodia. We had one of the only outbreaks in the world, but that's another story for another time. However, if you look at avian influenza reporting over the same time period, you actually see that increasing, okay? So, here we have, our general baseline, and then it's just kind of been going up over time since that time. And that's really concerning, okay? It's really concerning, and we need to look at it. And then if we kind of break that down a little bit further, what you can see here in this pink color is really those 2344B H5N1 viruses. So we see a lot of these viruses being reported, especially in Europe, North America, places where they're not normally associated with infection, and then now, of course, into South America. And so it's critical that we have a way to get ahead of this and a way to monitor this so that we can get ahead of these major outbreaks. But I also do want to point out that we still are detecting all these other kinds of avian influenza. That's equally important. Even though we're responding to one right now, all these other subtypes of avian influenza still exist in the world, and they will continue to circulate. There we go. So in Cambodia, specifically, AIV is endemic. It's been endemic since about 2004. At any given time when we're out in the field, this is an average, about 20 to 40% of chickens and about 30 to 50% of ducks are positive for some sort of avian influenza virus. That does not mean that it's a highly pathogenic avian influenza virus, but it does mean that we do detect some subtype of avian influenza. And so we've been doing longitudinal active surveillance in partnership with the Food and Agriculture Organization of the United Nations, as well as the National Animal Authorities for a number of years. And so we've also had a number of human cases and poultry outbreaks. So if I plot those actually on a year, what you see here is just human cases, poultry outbreaks, and then aggregate data from 2013 to 2019. You see these peaks and valleys, and I think you can kind of appreciate here this peak right here very early in the year, the peak we're in now. Interestingly, what this actually associates with is festival periods. So when people are actually actively buying more birds, they're farming more birds, they're buying birds to use for celebrations at home or to give their ancestors, we actually see peaks of these actually appear. What's interesting is that, and I didn't put it in this talk, but I'm happy to talk about it later, is that during COVID, when these festivals were either canceled or moved, the AIV prevalence went away, okay? So that really does indicate to us that it's a social, there's also a social component to all of this. But really what we've been able to do over the course of time is really monitor what's going on in Cambodia. So really we started with 112. We had a clade switch in 2013, 2014 to 2321C that caused a number of human infections. Since that time, we've now started seeing 2344 viruses that have now co-circulated with 2321C. And then, of course, you probably have all heard that we did have some human infections last week with 2321C as well. And we'll get to that a little bit later. But we're also monitoring things like H7 viruses. So we have Jiangsu lineage H7 viruses still circulating in the country and reassorting. And then, of course, H9 viruses, which of course, are less concerned to the human side, but very important to the agricultural side because of the loss of fecundity and things like that we really need to continue to monitor. They are low pathogenic at the current time, but they are still circulating in the region and they can reassort. And then we detect novel subtypes. So this is H14 that we've actually detected in poultry. This is normally a wild bird-associated virus, normally found in gulls and terns and things like that. We've actually been able to find it in poultry populations in Cambodia. And how have we done this? And it's really because of our commitment to early warning, okay? So through our projects, what we try to do with FAO and other private partnerships like with INDICAL is really get ahead of diseases. So, you know, it's critical that we anticipate what's going on. It's critical that we prevent those things from happening. It's critical that we can be able to detect those things when they do happen or before they happen. And then all of those come together for us to respond and break any chain of transmission that may occur. So these are the four pillars of essentially what we do. And so early warning in and of itself requires active surveillance. We all need to be out in the field actively surveying birds or other animals, and oftentimes those are negative, okay? That means they're very caustic, they're costly, they're time consuming. People are out in PPE in the middle of markets. It's a burden not only on scientists but also on the markets themselves. And that's a problem because to do the early warning, we need to do the hard work. So basically, and then of course, they're also in places that are not necessarily easily accessible. This is my team going out to a wild bird site in Prek Tual, which is the largest freshwater lake in Southeast Asia. And as you can see, they have to ride in these small boats and do a lot of work. So, you know, really what we're trying to do right now is to improve our ability to do this testing. And so we can do this with two main things. One is looking at our sampling strategies. Can we actually improve our sampling strategies at these high-risk interfaces? And then can we actually improve our testing capacity, not only in our labs, but also in the field? And so this is the largest live bird market in Phnom Penh. It's one of the slaughterhouses in live bird market. Apologize to everyone, it's right before lunch. But So you can see here, I hope you can appreciate here that there's a lot of interfaces that you could see spillover, not only from bird to bird, but also bird to human. And there's a lot of interfaces that we can use to actually do surveillance that don't have us actually handling the birds. So we can use feathers, wash water, surfaces, cages, things like that. But what we really want to talk about today is obviously air, because these viruses are circulating within the air system, and it's much more likely that someone's going to breathe in a virus than necessarily kiss a chicken, right? Okay? So understanding what the air in these high-risk interfaces is absolutely critical and can give us a lot of information. And so the device that I'm going to talk a little bit about today is the AeroCollect. You probably have heard about it from INDICAL. We're trying to employ this type of device in these high-risk settings. So I'm going to talk mostly about the AeroCollect, but also some other devices today, and how we can actually move forward novel technologies in surveillance to actually give us better information. So we've been doing air sampling in live bird markets now for about 2 years. This is a different product, but it's still an air sampler, you can see. This is a bigger bash sampler. Putting them in markets in high-risk locations, putting them next to slaughterhouses, and things like that, and really looking at what we can detect. And what we find is that we can detect avian influenza exactly the same as we can detect in 40 samples from birds, okay? So if I take an average CT, so average viral load here, yes, it's going to be lower in a bird, but I can detect it in the slaughterhouse, in the storage of poultry, and even in the food sales area, which are physically separated from the slaughterhouses, okay? So that tells us a lot about not only what's going on in the market, but it also tells us that maybe we need to do an intervention and change the HEPA filters or the airflow within that market as well. We can detect every single subtype as we detect in chickens. So here, if we're detecting H5, H7, H9, we can also detect H5, H7, and H9 in a single air sample instead of in individual birds. So you can see the utility of this kind of off the bat. We've used different types of samplers. Here I have a person wearing a personal NIOSH sampler. So these are filter-based samples. We had them wear these for 30 minutes only every day for a week during the peak. Remember that peak I showed you of AIV? And what we found is that there's a 100% chance of someone in that market actually inhaling a viable avian influenza virus just from wearing it for 30 minutes. Okay, so you see this is a massively risky interface that we need to get ahead of. And so now we can do this handheld. So we've been out in the markets comparing sampling in birds as well as other air types with what we're here to talk about today is, of course, the AeroCollect sampling system. So here you see we're sampling some ducks, but also we can hold them over things like defeathering machines to look at aerosols. Yeah, it looks like he's talking in a microphone or something like that. But they're super portable. We can go directly to the places that we are actually looking at to look for an interface. We've been, just to give you an example, so can we actually use this in a live bird market to detect avian influenza? So I went out one day and just took a bunch of different samples around a market. So we took samples in kind of the rearing chambers and the small birds. We took samples, and again, these are just 10-minute samples, okay? I just went to each of these places, held this for 10 minutes over that area, and then collect the samples. So this is a bird storage area. This is a defeathering machine, and then in a food sales area, okay? And what I found is I was able to collect H9N2 at this location at that time. We've done a lot more of these studies since, and I don't have all data to tell you all the data I have, but we are getting really, really interesting results comparing bird samples with air samples within the market. We're also doing a number of studies now looking at how long you have to hold these things and how and where and how. So hopefully that will all come out a little bit more soon. So this is my Fulbright scholar, Ben. He was very excited when we got some more of these. So how can we actually move these things forward? So obviously we're talking about birds and AIV, but can we actually move this a bit further? So What I want to show you here, these are actually wild bird colonies. So these are actually Asian open-bill storks. So each one of those little white dots is actually a nesting site. And this is taken by us out in that lake that I showed you before. So we know a lot of these outbreaks actually occur in the wild. So can we actually take these out into an open environment and use these to detect AIV? And when we do find wild birds, we do take these collectors out into the environment and actually look, and we are actually able to detect AIV in those as well. There's also other interfaces that we want to look at. So we're obviously here at VIV Asia, so let's talk about some other animals. So pigs obviously are another interface that we're quite interested in. So can we actually use these in pig slaughterhouses? And we have been using these actively in pig slaughterhouses, comparing against direct nasal swabs as well as cage swabs and things like that. Luckily, we have not detected any flu in the pigs that we've surveyed in these projects yet, but there are other diseases, things like FMD we're able to pick up in the air. At one point, we're able to pick up JEV. So there are a lot of other things you can use these collectors for besides just necessarily agricultural or AIV. We also use them on wild animals. So here you see my team swabbing a civet, a captive civet with the AeroCollect in the bottom there. We do a lot of active surveillance on wild animals for coronaviruses and other potentially zoonotic diseases. We are able to detect pretty much everything that we're getting out of that swab, also in that air sample as well. And then finally, bats. So we've been very, very interested in bats for about 25 years. Here you can see an air sampler underneath about 1 million bats flying out of this cave at one point in time. We're having really, really good luck with these, where if we compare guano and urine samples from the same time period and one air sample, we see the same things as well. And so now even we're going further with this. So obviously we can carry these things around. We can do this very well, but a lot of these places that we're looking to use them, we can't get into. Okay, so think about a cave on the top of a mountain. Think about farms that maybe they don't want people walking through. Think about going out in the ocean and getting whales and dolphin samples and things like that. So we're actually using these things remote as well. So we can strap them to the top of a drone and fly it around. And that's sort of the focus of this year is going to be flying these into inaccessible spaces that we can actually use that sample to assess risk very, very quickly. We've also generated terrestrial-based versions of these. And these are really for driving into farms and other places and allowing the animals to come to and we went and bought a remote control car today. So if anyone wants to come and play with these things. So this is on probably the smallest of cars you can even see, and I'm not going to drive this well today, but you can see that they handle pretty well even on the smallest of vehicles. They think they even, oh yeah, we even have smoke on this one. You can see the utility of this where you're entering into your farm, you're entering into your bat cave, you're reducing the risk not only to your staff for going into these dangerous places, but also to potentially extremely endangered animals and things like that. We can get them even further remote as well. And we're working with a number of people on generating new types of drones and things like that as well. So the other thing I wanted to talk about a little bit is testing. Obviously, if we have better ways of collecting samples, increasing our ways that we test them is also important. We can do this in a number of ways. So not only do we want to increase the sensitivity and specificity of our individual tests, but we also want to increase the speed and versatility of those tests. And then, of course, we want to be able to use them to discover new or high-risk pathogens at points of risk. One way we can do this is really multiplex testing. INDICAL does have a very nice avian influenza multiplex system We've used this for a number of things, and we have verified it with a number of different pathogens. So this kit is able to pick up H5s, H7s, H9s, things that are circulating in the region, but also it does come up positive for other subtypes as well, which is really, really useful. We do have to do a little bit more work on those, but these all are all detectable by that multiplex kit. Another thing that we're looking into, and I don't really have a lot of time to talk about today, is obviously field PCR. There are now very, very nice field PCR machines that provide pen-side solutions. This one right here is a 3-color machine, but there are also other handheld devices. And so now we're moving these into field-based studies as well, not only using these for detection at pen-side, but also for things like sequencing. Okay, so having a PCR machine in the field actually allows us to do thermocycling and things like that for in-field sequencing. And we've done a lot of work on rapid diagnostic sequencing in the field and in the lab. And we've been able to, I think most forward has been this integration of a integrated barcode multi-segment PCR for flu surveillance. So really rapid AIV surveillance that we can use to identify subtype. This is a system that we've developed with our partners at Johns Hopkins Applied Physics Laboratory, and really it utilizes some multi-segment PCRs that are integrated barcode and the nanopore technology, that then we have some basically gaming laptops that we have bioinformatics on, so they're all completely, we don't need the internet, we don't need power, we don't need anything like that. We can do this completely independently. These systems are so good that within 10 minutes of getting that sample onto the system, it actually starts spitting out exactly what's in your sample. So here it's showing 6 different samples with 6 different subtypes of flu, and it's giving you even the PB1 and PB2 genes of that virus as well. So you can imagine how useful this might be in the field or an outbreak setting where you have a flock dying of AIV, you need to know what it is, or in the case of human infection, we've used this quite well for 2 H9 infections in 2021 and 2022 in Cambodia, and then of course with the H5 infection that happened last week in Cambodia, where unfortunately a young girl died. But we were able to go from clinical sample to sequence in less than 24 hours and get that out in the public database within 3 days. Something that shows that we can actually be very, very open and clear with what we're doing. We were able to sequence the father as well, and then further poultry testing is ongoing. The other thing I want to talk a little bit about is moving further on that point, which is really, can we combine metagenomics with these environmental samples, and what does that mean? This would greatly expand our ability to detect not only the pathogens of interest, but also discover new ones. So here you see a bird flock in Cambodia in a lake. And so we have run a bunch of different assays on these things. So here I have a pool of poultry cloacal swabs that we ran metagenomics on. You can see it's 98% influenza in that swab, which makes sense because they were influenza-positive birds. However, if I compare that to just one air sample taken at the same time, you can see a much greater diversity of what we're detecting. So not only influenza, but also tons of different rotaviruses, other avian viruses of concern, but also things like bat, human, carnivore, and other viruses within that system that may be of interest. A lot of these are also almost full genomes as well. Moving in even further, we've done this with a number of different things, and so here this is just kind of some preliminary work, but here on the left we've just made a heat map. These are viral families, and so this red color up here is actually air samples, okay? The other colors are different kinds of samples that we collect in the market, but I think you can appreciate very quickly how diverse these samples actually let us see into that market ecosystem compared to just individual birds or individual water samples. So I'm really hoping that this will be kind of the future of what we're doing once we figure out a good way to do this in the field, and then of course use that for actionable results, because we can tell you all this data, but we need to be able to tell policymakers and company owners and things like that how to use this data to actively combat whatever pathogen they're interested at the time. So in the future, obviously we're going to continue surveillance. We need to maintain this longitudinal surveillance, not only in domestic animals, but in wild animals and humans. We want to continue to improve all of these diagnostics with wonderful collaborations with companies like INDICAL. We'll continue our studies at the wild-domestic environmental interface, so especially bringing out these novel ways of detecting viruses or pathogens even in high-risk species and novel interfaces. We're going to continue to incorporate this technology into our surveillance programs and hopefully expand that to other places and other sample types. Obviously, we need to consider the socioeconomic and endemic issues that surround this as well. Can this novel sampling actually help to improve our relationships with producers, with other people? It means we're not going out into bat caves in full PPE and scaring people and things like that as well. And obviously helps our pathogen value chain. We need new strategies for response and control. Obviously looking at stamping out versus vaccination, communication and collaboration globally. And then finally surveillance for other diseases. So again, that metagenomic approach to everything. And so with that, I just, of course, need to thank INDICAL very, very much for having me here, for allowing me to take your toys out in the field and break them sometimes, but for really pushing things forward. And I think it's really progressive view to have these public-private partnerships where we can really push the science forward and use that for actionable items. And then, of course, everyone that we work with at IPC. And I've probably forgotten at least one or two people here, but I think they'll forgive me. So with that, I'll take any comments or questions as well. Thank you.
Has anyone used air sampling currently in their current testing regimes? So, Eric, I do have a question. So, when you're looking at using air sampling as a technology, what do you think is the true value of that over the traditional methods? More in, like, if you look at it, obviously we've talked a lot about wild bird, but in traditional farming, do you know where you would see the advantages in that?
So there's a number of advantages of environmental sampling over standard flock checking, right? I think we have to be clear about what we're looking for, right? So standard sampling from individual birds obviously tells us the prevalence within the flock, how far it's spread, if there's asymptomatic infection, all the things that we really need to know, especially during an outbreak and things like that. But environmental sampling, because it allows us to sample a larger area of space, it gives us more information about what's going on in the environment. It tells us an average of kind of what's happening in that flock. It's more cost effective. Sometimes it's a lot faster. We don't actually have to take the sample back to our lab all the time anymore. And it's easily deployable. You don't have to handle the birds. You're not stressing out your flock. You're not stressing out a bat or potentially being bitten by a bat, things like that. So there's a lot of benefits that you can look at. But that's why we need to benchmark, do the studies that we're doing now, which is benchmarking it against traditional methodology and understanding when those are applicable and when we need to do both or when we need to go standard.
So when you talk about that, if I look at what
In my opinion, it's easier to train someone to sample air than it is to bleed a chicken or a duck or even swab a duck, because handling has to happen very carefully and things like that, versus handing someone this and saying, press the green button. You know, that's kind of easier, right?
If I may add, Eric, because actually this is great, and I think it speaks how we can really be in the wild and really start creating surveillance extremely early on. And I think what Erik has been doing is amazing. We've been working with large poultry integrators as well, because this device has very strong application for the standard poultry industry. And I would say two things. One is earlier detection. So the quality of your detection is better than traditional, meaning that you can actually detect things earlier. And obviously this has huge productivity and economic implication. And the second is ease of use. And it's not only training people to walk with a device rather than taking samples, but it's also, and maybe we didn't spend enough time on that, this device allows you to go straight into PCR. So you don't need to do any extraction. So if you think about the workflow and the costs associated to sampling and executing a PCR test, this actually reduces quite significantly. So that's the way we see it, and we're working with, I see Avian here that is quite interested, and probably you guys are, I don't know if you have any comment. You've been...
No, I know we have. I mean, I got that device with me when I was in India, visiting our internal operations. I know it's something that we are also testing, and as you said, it's not just Avian Influenza, it's Mycoplasma, Salmonella, whatever you want to use. We are still also trying to benchmarking with traditional methods or commercial farming, let's say. But I find it very interesting, and for things like Avian Influenza, you are going to go always ahead of infection when you are checking seroconversion. If you have an H9, you are always going to find it far earlier in an environmental sampling than in the blood. And so you can go ahead of time and know what's going on and then make the right decisions. What we were wondering also, now we were discussing, you were talking that you were having for like 10 minutes when you have that wild bird. Have you been comparing timings, exposure, and can you give us some ideas of what's the best?
We've just started those studies in mine. I know they have done some studies with different times that they've been holding the device in farms and things like that. So maybe I'll let Alison touch on that.
Yeah, I don't know, June.
Yeah.
So AeroCollect, Force Technologies actually offers it as a screening service in Europe, and they use traditionally in standard operations 5-minute screening times. But what we've found in some parts of Asia is that you need to look at optimization. So it comes more down to what question are you asking? Are you looking to do something that is the most sensitive method, and then the type of pathogen also comes into that. So we're happy to have discussions about what you're trying to do. Please come up and see us. Julia and I and the team are happy to come and have a discussion with everyone about what you may think you could use this technology for in managing your diseases in poultry and other species.
For the companies, do you have any plan to, like any other parts of the world that do similar kind of testing like this? Are there any others or any future plan for the company?
So you mean geographically?
Yes.
Yeah, I mean, as I mentioned, actually we're working as INDICAL around the world on this. So we actually engaging customers in North, South America, in Europe, in Asia. So, and we're really trying to tailor the approach based on the need. I mean, obviously in Asia, I think wild markets, it's an extremely important way to look at things. In others, and as Alison mentioned, we're really trying to adapt to the local needs. Every local environment is different. and so adapting the workflow to the best user. But we're seeing good, results, and validation is now not a question at all. It's more how you optimize it also to get the best out of the stream. Because from one chamber also that you can go straight into PCR, you actually can test 4 pathogens from one chamber. So how we also optimize the pathogen we're really looking for, and how we optimize the cycle of vaccination. All these things then come together but yeah, this is a global solution. And in Europe, AeroCollect has been doing a lot of work in the Scandinavian region as well, with a lot of good results. So.
Yeah, Eric, I have a question. So if we push the reflection further to the prevention side, so do you think, or have you get any experience on the potential application, for example, for vaccine take monitoring, especially when using live vaccines, or even the possibility to use this device as a beta test to differentiate infection from vaccination?
That's a complicated question. Obviously, if they're using live vaccination, we can detect those in traditional samples, right? So if they're putting in the water or something like that. I have not tried this technology with vaccine strains or anything like that yet, but we do pick up things like IBV and NDV, which already have live vaccination, right? And so we can see differences in wild versus vaccine type IBV in our samples, but they still require some pretty intense molecular detection to understand the difference between the two, right? But you can pick them up in the samples. So eventually the protocol would be great to have an in-field collection and then a test that you could use on a multi-target PCR or something like that. That would differentiate for you as well.
Do we have any other questions? I want to thank everyone for coming along. So I'm the regional director for INDICAL. And so if you do have any questions, if you're in this region, please reach out. I'm here to help. I come from a science background, and I work closely with my team who are all across the world. But also we have some lunch for you outside. So please join us for lunch and ask us questions about your situation. Every situation is different, and we want to discuss how it can be implemented to help address your concerns and your questions. So we have worked with vaccine monitoring for looking at shedding of live vaccines, but also looking at infection after dead vaccine and optimizing the vaccination points, right, with vaccines. But each of those questions are independent, but the different use of this technology can allow you to look at those different approaches. So thank you very much.
Thanks, Eric.
Thank you.